So in this problem, we need to verify that 1 plus sine 2 theta plus cosine of 2 theta divided by 1 plus sine 2 theta minus cosine of 2 theta equals the cotangent function. So let us begin our proof from the left hand side. So here we have on the left hand side 1 plus sine 2 theta. Now sine 2 theta is a trigonometric ratio of a multiple angle, so that can be also expressed as 2 times sine of angle theta times cosine of the angle theta. So we'll replace the sine 2 theta with 2 sine theta times cosine theta. Then added to it will be cosine 2 theta. However, there are 3 forms of cosine 2 theta. So we have cosine 2 theta equivalent to, we have the main one, which is cosine squared theta minus sine squared theta. Then we have 2 times cosine squared theta minus 1, and we have one more form, 1 minus 2 times sine squared theta. Now out of these 3, we're going to choose the value of cosine 2 theta in such a way such that it gets that this one gets cancelled out. So what we'll do, we'll use the second one, which is positive 2 cosine squared theta minus 1. Coming to the denominator, we have 1 plus sine 2 theta. So sine 2 theta can be also expressed as 2 times sine theta times cosine theta. And then we have negative cosine 2 theta. So negative cosine theta, we have to choose very carefully. We are going to use the second one such that we have negative 1 plus 2 sine squared theta. And we have chosen the third one because we want to cancel out the 1. So in the numerator, we have 1 and negative 1. And in the denominator, 1 and negative 1, cancelling out with each other. Now, we are left with 2 terms in the numerator and the denominator. From the 2 terms in the numerator, if we take 2 times cosine theta as the common factor, then this will get multiplied to sine theta plus cosine theta. Divided by the denominator, we also have 2 terms. So we're going to take 2 times sine theta is the common factor. So that gets multiplied to cosine theta plus sine theta. Now, sine theta plus cosine theta, that's a common factor in the numerator and the denominator. We can factor it out. We can also factor out the 2. So we are left with the cosine function to that of the sine function, and this ratio is the cotangent function, which is the expression on the right hand side. Hence, proved.